In Lecture 7E, we're going to talk about a few hybrid storage systems that differ from the traditional distributed file systems that we've discussed previously. So in discussing hybrid storage systems, I'm not going to give a strict definition of a hybrid system as related to a traditional distributed file system, but I will mention that a number of them abandon POSIX compliance, whether for architectural optimizations or performance reasons, where what the particular application is doing doesn't require all of the semantics that come along with a POSIX specification. And I'll also note that for most of these file systems, there are adapters such as Fuse that you can add to one of these hybrid systems that gives it POSIX-like behavior and or at least makes the majority of your applications work on top of these hybrid systems. Should mention a lot of these hybrid systems have varied or maybe niche applications, such as, which is very popular right now, data analytics in terms of data mining and deep learning. We also have consumer-focused hybrid storage systems, such as cloud storage that we've come accustomed to, whether that's through Apple's cloud service or Amazon's cloud service, Google's, Microsoft, etc. And then you can also think of all of the data warehousing and archival purposes that industry and enterprise might use. When you come up with a hybrid system, though, and you start looking for optimizations, you go from what is more of a traditional architecture to something that is more hybrid unicorn sort of looking. So we can start with our traditional servers, but we start adding on pieces and parts. If we add on a unicorn horn and a serpent tail, suddenly the way that we expected our traditional file system to behave, the hybrid system may have some more non-intuitive optimizations or some peculiarities that gave it that specific performance boost, but may operate in a way that's maybe not intuitive to a user. A couple examples. Some of you may be familiar with Google Drive, and it has some great characteristics. It's one of these consumer-focused cloud storage with some enterprise uses out there. It has unlimited academic capacity. So why not? Why would we use anything else other than Google Drive? Unfortunately, it doesn't have a Linux sync client, so we can't put it on the majority of Linux clusters where a lot of the scientific and data-intensive science is happening. And there's some reasons for that. Some of it may be more commercial and business than actually technical, but then you also have things that you have to consider, such as slower transfers. This is out in the cloud somewhere. While your institution may have the ability to cache certain amounts of what's in Google Drive locally to speed things up for you, in general, you're still getting that data remotely, whether it's to a cache somewhere else on your campus or you're going all the way out to one of the Google data centers. So it's not necessarily always going to be at the performance you need for your more data-intensive scientific applications. We'll also talk about the Hadoop distributed file system and how it's hybrid compared to a traditional file system, and why we need Fuse to put on the front of that to adapt it such that your applications might be able to actually leverage data that's stored in Hadoop. So with that, we want to make sure that you understand that these various hybrid systems may introduce better performance and lower cost, sometimes simultaneously, if you're able to understand those kind of non-intuitive optimizations and various peculiarities that will differ from a traditional file system. And you can adapt your data-intensive scientific workflow such that you can capitalize on these various hybrid file systems.